Welcome to another Chapter 3 video. Again, descriptive statistics. We're dealing with box plots and outliers. These are based on the position of data relative to other data rather than the actual values themselves. So for a particular set, I am looking at what's already been created as the 5-number summary. You can look in the textbook or on Connect Math examples for how to find that 5-number summary. It deals with position of data rather than the actual data values themselves. The minimum is self-explanatory. It's the smallest. Q1 is the first quartile. And that means 25% of the data is below this. So 25% of the data is 17 or lower. So, and first of all, to create the box plot. It is indeed a plot. It is a graph. So it needs a title. Just like our Chapter 2 videos. It's a graph. It needs a title. There's no information about what this data represents, so you just have to indicate that it does in fact have a title. Box plots need a number line. It has to begin with a value of at least the minimum and use nice values. In this case, 10 is a good, nice value less than 12. And then use nice steps. And in this case, steps of 5 would be nice, 10, 15, etc. So that would be our number line usage for that. It's got at least the smallest, the 10, at least the biggest, and they are using nice values. For the box plot then, you make hash marks for each of those 5-number value points. So the first one there, marked even with where 12 should be. The second one where the 17 would be. And then the 21. And then the 26. And the last one being that 40. The middle part there is what creates the box. And then you arrow out to the ends. It's also referred to in some instances as a box and whisker plot. So that's what would be used for there. For that, there are no values given on the particular set itself. I'm not identifying the numbers here. That's not part of the graph to say and identify the numbers at that spot. Things that you don't want are to identify that. I don't want wasted space. I don't want this going out 45, 50, 55, etc. That's wasted space and isn't necessary. Just like I wouldn't go down to 0. So those are items to keep in mind when making the box plot. When dealing with outliers, you first of all have to identify what's called the interquartile range. noted IQR. It is a range of that middle 50%, Q3 minus Q1. The largest minus the smallest value for the middle 50%. Our data set, that is 26 minus 17, which is 9. That's what used then to find what are called the cut values. First of all, the lower cut, which is Q1 minus 1.5 times the interquartile range. So Q1, 17 minus 1.5 times 9, and that happens to be a 3.5. Anything less than 3.5 would be an outlier. There are none below. There are no extreme values on the lower end of this data set. For the upper cut value, Q3 plus 1.5 IQRs, interquartile ranges. That is now 26 plus 1.5 times 9. That is a 39.5. 40 is greater than that. So there are outliers above. We don't know for this particular example what they are, but at least 40. There may be a 39.8. There may be a second 40. We just know that they do exist. So that's calculating outliers and creating box plots.